At first glance, the thought of being trapped underground, cut off from the surface, surrounded by darkness, and unsure which direction leads to safety feels like something out of a survival thriller. But for miners, spelunkers, tunnel workers, and even search and rescue teams, subterranean survival is a real-world concern. Whether it's a cave-in, equipment failure, or sudden loss of orientation in a complex tunnel network, knowing how to survive underground requires clear tactics, calm thinking, and an understanding of the environment below our feet. Let's take a step back. When a person enters a mine, cave, or tunnel, they're stepping into a hostile, often unpredictable environment. Unlike surface emergencies where help may be just a phone call away, underground situations come with unique challenges. Unstable geology, pitch-black conditions, limited oxygen, and narrow or collapsing paths. Once something goes wrong, your survival depends on what you do in the first few minutes and how well you've prepared. One of the most immediate dangers is a cave-in or tunnel collapse. When part of the ceiling or walls gives way, the instinct might be to panic or try to dig out, but this can be dangerous and exhausting. A key survival tactic is to assess your space. Are you trapped in a small void? Do you have breathable air? Is your body injured or pinned? If you're safe from further collapse and have room to breathe, the first step is to conserve energy and air. Movement stirs up dust and consumes oxygen. Remain still, cover your mouth with clothing to reduce dust inhalation, and breathe slowly. Rescuers often rely on sound cues to locate survivors, so tap on rock or metal in regular patterns, not by shouting, which uses precious oxygen. If possible, mark your location with anything that reflects light or sound. Navigation underground is another challenge. Natural caves and man-made tunnels can resemble labyrinths, where left turns, slopes, and dead ends disorient even experienced explorers. The key is to leave a trail. Chalk marks, reflective tape, or even a string reel, a classic cave diver's tool, can guide your way back. If you're exploring or evacuating, follow air currents. They may lead toward larger openings or ventilation systems. And remember, down is not always safer. Going deeper might trap you further. If unsure, stay put, especially if you've signaled your location and expect rescue. Then there's the issue of oxygen management, which becomes critical in confined or collapsed spaces. Underground environments may already have low oxygen and high carbon dioxide levels, particularly in unventilated mines. Fire, physical exertion, or breathing in a sealed area accelerates oxygen loss. Some advanced kits carry chemical oxygen generators or rebreathers, but in many survival situations, you're relying on the air already around you. If you suspect a drop in oxygen, symptoms include headache, dizziness, confusion, and rapid breathing. Your only option is to limit exertion and air usage. Curling into a smaller space can reduce the amount of air you exhale into your immediate surroundings. In group situations, communication and psychological resilience are crucial. Panic spreads quickly underground. Establish calm leadership, rotate responsibilities like tapping signals, and keep track of time and signs of dehydration or hypoxia. Darkness can disorient your internal clock, so it's helpful to assign shifts for rest. Even if it's hard to sleep, light, if available, should be preserved. Use it sparingly but strategically, flashing to signal movement or using reflected surfaces to amplify visibility. Preparation, of course, is the ultimate key to survival. Before entering any underground space, proper equipment should include helmet with headlamp and backup lights, fresh batteries and spare bulbs, portable oxygen or air quality monitor, navigation aids, maps, string lines, chalk, emergency rations and water, compact thermal blanket, communication gear like radios or underground signal transmitters if available. Could you survive underground for hours or even days with no light, limited air, and shifting rock above your head? It's terrifying to imagine, but history shows it's possible. Think of the 2010 Chilean mine rescue, where 33 miners survived 69 days underground before being brought to the surface thanks to planning, discipline, and rescue efforts. Ultimately, subterranean survival isn't just about having the right gear, it's about having the right mindset. The underground world is alien, disorienting, and dangerous, but with knowledge, preparation, and a calm, problem-solving approach, Even the most claustrophobic spaces can be navigated, endured, and survive. Understanding the subterranean environment. Subterranean survival begins with a deep understanding of the underground environment, where conditions can rapidly change and hazards such as cave-ins, limited oxygen, and complex layouts are common. Knowledge of geology, soil mechanics, and the behavior of rock formations is critical for assessing risks in cave systems or tunnels. Being aware of natural features, water ingress, and historical collapse patterns helps in predicting dangerous zones and planning safe routes. This foundational knowledge sets the stage for developing effective survival tactics in confined underground spaces. A researcher might notice that certain plants thrive in one area but not another, and then ask, what environmental factors are causing this difference in growth? It's like a sailor checking weather and ocean current maps before venturing into potentially stormy seas. Understanding the environment is the first step towards safe navigation. Tactics for preventing and responding to cave-ins. Effective tactics for dealing with cave-ins involve both preventative measures and emergency responses. Structural monitoring tools such as ground-penetrating radar or seismic sensors can provide early warnings of shifting rock or unstable formations. Proper support systems like rock bolts, wooden or metal props, and mesh screens can be installed to reinforce weak sections and prevent collapses. In the event of a cave-in, having clear evacuation routes and emergency communication protocols is vital for survival. In mining operations, continuous monitoring of ground movement using seismic sensors allows engineers to reinforce vulnerable areas before a collapse occurs. It's like installing smoke detectors and sprinklers in a building. These systems help prevent a fire from becoming catastrophic and provide a warning if trouble arises. Strategies for underground navigation. Navigating underground spaces requires precise mapping, situational awareness, and the use of advanced technologies. Since traditional navigation tools like GPS are ineffective, techniques include pre-mapping the cave layout using laser scanning, using natural landmarks, and following established routes. Modern devices like inertial navigation systems and low-frequency radio beacons can help maintain orientation in the absence of sunlight. In addition, planning and communication with team members ensure that any changes in the environment are quickly shared and integrated into navigation strategies. Cave explorers often create detailed maps using LiDAR and 3D scanning, which are then used to guide teams safely through complex winding passages. It's like navigating a dense forest with a meticulously drawn map and compass where every landmark and trail is clearly marked to avoid getting lost. Oxygen management and air quality control. In confined underground spaces, oxygen levels can quickly become depleted, while carbon dioxide and other toxic gases accumulate, posing serious health risks. Effective oxygen management involves monitoring air quality with gas sensors, employing ventilation systems, and carrying portable oxygen supplies if necessary. In some cases, chemical scrubbers or filters can remove harmful gases to maintain a breathable atmosphere. Planning for these scenarios is critical, as even a small lapse in air quality can have immediate and life-threatening consequences. Rescue teams working in collapsed mines use portable oxygen tanks and CO2 scrubbers to ensure that trapped miners have access to clean air during their extraction. It's like ensuring that a submarine has a well-regulated air supply system. Without careful management, the confined space could quickly become uninhabitable. Essential equipment and protective gear. Equipping oneself with the right gear is paramount for subterranean survival, including helmets, headlamps, respiratory protection, and robust communication devices. Protective clothing and gloves can safeguard against abrasions, sharp rocks, and sudden temperature changes. Specialized gear, such as self-rescue devices, inflatable lifelines, and portable gas monitors can provide critical support in emergencies. Ensuring that equipment is well maintained and that users are trained in its proper use is a key aspect of preparation. In cave rescue operations, responders wear full protective suits with integrated headlamps and communication devices to navigate safely and maintain contact with the team. It's like a deep-sea diver donning a full wetsuit, oxygen mask, and underwater communication system to withstand the harsh conditions of the ocean depths. Risk assessment and emergency planning. Conducting thorough risk assessments before and during underground expeditions is essential to identify potential hazards and plan for contingencies. This includes evaluating the likelihood of cave-ins, the stability of the environment, and the available escape routes. Detailed emergency plans should cover immediate actions in the event of a collapse, oxygen failure, or navigation error, with predefined roles for team members. Regular drills and simulations can ensure that everyone is prepared to act swiftly and effectively under stress. Mining companies conduct regular safety drills and risk assessments to prepare for unexpected cave-ins or gas leaks, ensuring that all workers know their roles during emergencies. It's like practicing a fire drill in a school. Everyone rehearses the escape plan so that if a real emergency occurs, they can evacuate quickly and safely. Training and psychological preparedness. Beyond physical equipment and technical skills, effective subterranean survival relies on thorough training and psychological preparedness. Individuals must be well-versed in emergency procedures, first aid, and stress management techniques. Regular training sessions and simulations help build confidence and ensure that teams can function cohesively under pressure. Mental preparedness is as crucial as physical readiness, as fear and panic can exacerbate an already dangerous situation. Cave exploration groups often participate in simulated rescue exercises to practice remaining calm and following protocols in low-light, high-stress environments. It's like athletes training not only physically but also mentally for a competition. Preparing the mind is essential to perform under pressure. Utilizing technology and innovations. Emerging technologies are continuously enhancing subterranean survival strategies, from advanced sensors and robotics to augmented reality, AR navigation aids. Drones and robotic devices can be deployed to assess unstable areas and gather data in places too dangerous for humans. AR glasses and headsets can overlay navigation maps and hazard alerts onto the explorer's field of view, providing real-time situational awareness. These innovations promise to improve safety and efficiency in underground operations dramatically. In recent rescue missions, drones equipped with thermal cameras have been used to locate survivors in collapsed structures, while AR devices guide rescuers through complex passageways. It's like having a personal assistant that projects a digital map onto your glasses, highlighting safe routes and potential hazards as you move through a maze. Future directions and the evolution of subterranean survival. Future advancements in subterranean survival will likely focus on further integrating smart technologies, data analytics, and real-time communication to enhance safety in underground environments. Research into novel materials for better protective gear and adaptive ventilation systems will improve survival rates in confined spaces. Collaboration between engineers, geologists, and rescue professionals is paving the way for more resilient infrastructure and emergency protocols in subterranean settings. Ultimately, as our understanding and technology evolve, so too will our ability to safely navigate and thrive in the underground world. Ongoing projects are developing wearable sensor networks that continuously monitor environmental conditions in real time and automatically alert rescue teams to changes that may indicate impending danger. It's like upgrading from a basic alarm system to a fully integrated smart home system that detects and responds to every potential threat, ensuring that the occupants remain safe no matter what happens.